In this video, we are now going to look at graphing using standard form. Standard form is probably the form that we're going to see the most often. You can always transform standard form, which is y equals ax squared plus bx plus c, into vertex form by completing the square. It is a lot of work to go through the process, but it definitely is possible. If you remember completing the square from Algebra 1, feel free to do that. The issue is some of those are not always going to be the nicest types of numbers. You're going to get lots of fractions. We will be able to graph standard form using the process I'm going to map out for you. If you do not know how to complete the square, we will actually look at completing the square in a little while. So to begin with, there's different pieces of information you need to know. A, B, and C are numbers. Those are coefficients to each of these. So they're going to be some type of number, a 1 or a 5 or a -8, different pieces like that. So to begin with, the A value will tell you whether it's going to open up or if it's going to open down, whether the vertex sits at the peak of the graph or if it's the lowest part of your graph. Next, there's an axis of symmetry through the vertex. So here is a generic quadratic. So the axis of symmetry goes through the vertex. Here is my vertex, my lowest point, for instance, in this problem. There is symmetry that falls through it. Every point is reflected over. So there's a point here that's reflected over here. There's a point here that's reflected over here. This is a vertical line, which is an x equals. So there's an axis of symmetry that's an equation. It's an x equals equation. Across that axis of symmetry, there is called a symmetric point. So if I give you one point, you can find its what's called symmetric point. There are an infinite number of symmetric points. So if I have that point there, its symmetric point is this point over here. The reflection piece is really nice when you're trying to make the rest of your graph. If you didn't, for instance, go from the vertex around, if you're missing one side of it, you can find that axis of symmetry and start reflecting those coordinate points over. The next thing that we can find is the y-intercept. The y-intercept is probably the absolute easiest thing to find in our quadratics because the y-intercept, if you think about what is a y-intercept is where it crosses that y-axis, and that occurs when x equals 0. So in my equation here, I'm going to put 0 in for x. So what's 0 squared? 0 times a, 0. That's gone. What's 0 times b? 0. It's just c that's left over. So that y-intercept is one of the easier pieces to find when you're looking at your graphs. And then the last piece that we are going to look at today is finding the vertex. The vertex, the x value of it is the part that we'll find. And after we find that x value, then we're going to plug that number into the equation to get y. So for instance, say x equals 2, you plug 2 in for x. Do 2 squared multiplied by whatever that a value was, plus whatever that b value is times 2 plus c, and it spits out the y value. It gives you that coordinate point. Now, to find the x value of the vertex, it's using this small little formula, x equals the opposite of b over 2a. Now, you might look at that and go, hey, that looks familiar. You're right, it does. It should. It's actually part of the quadratic formula. X equals the opposite of b plus and minus the square root b squared minus 4ac all over 2a. Now in another video you're going to be looking at finding x-intercepts. So we're not going to look at x-intercepts now, but this one does at least give you your y-intercepts. X-intercepts is done by using the quadratic formula. Just a quick little side note of why is it the opposite of b over 2a? It's not just some random piece. Well, that just difficult part goes away. It's the opposite of b over 2a. But why is it that? It's not just a trick. There's an actual numerical reason for that. Part of the reason for this, if you think about any kind of quadratic, I'm going to draw a different graph. So here's my nice quadratic on my coordinate plane. And if I'm looking at trying to find the vertex, I have to find what's halfway between 2 points. So, gotta draw it a little neater for you. So I'm trying to find halfway between, because here's my vertex, right there. And it's this far over. Well, how do I find that x value? Well, it's the opposite of b over 2a, because I told you. But realistically, why is it that? Well, let's think, for instance, I have this value here, which say is 5, and I have this value here, which is 7. What's the x value of my vertex? 6. Okay, so this is 4, and this is 6. What's that halfway point? 2 and 6. 4. Average them. You take the two values, you add them up, and divide by 2. So that's how the quadratic formula actually works, is it gives you the two x-intercepts. So in generic terms, here's why it works. This intercept here is the opposite of b plus, we'll actually do minus the square root of b squared minus 4ac all over 2a. So that's that point there. This point here is the opposite of b plus the square root of b squared minus 4ac all over 2a. Because think about it, you get two different values when you're doing the quadratic formula. There's a plus, there's a minus. So with this, I have to average those two values. So add them up, divide by 2. Opposite of b minus the square root of b squared minus 4ac all over 2a plus the opposite of b plus the square root of b squared minus 4ac all over 2a. And I'm averaging them, so I add them up, and I divide by 2. I know it's kind of getting messy, but all of a sudden, watch what happens. Let's just look at my numerator. They're both all over 2a, so they have a common denominator already. So I'll rewrite that 2a. And now I'm going to add the numerators. I'm going to rearrange the order, though. There's a negative b plus a negative b, and then I'm going to make this a plus a negative square root of b squared minus 4ac, plus this time it's a positive square root of b squared minus 4ac. So that's my numerator, and that's still all over 2. Well, if you look, there's a negative 1 and a positive 1. Let's see. They cancel. And a negative b plus a negative b is a negative 2b all over 2a. That's my numerator. All over 2. Simplify that numerator. 2's cancel. So I get the opposite of b over a all over 2. Now this is where you have to think about, okay, division is the same thing as, I'm going to rewrite that out. That fraction bar, opposite of b over a divided by 2. Division is the same thing as multiplying by the reciprocal. Cross the top, cross the bottom, opposite of b over 2a. That gives you the x value of your vertex. A little bit in depth as to why it works, but part of the reason I wanted to show you that is I don't want you to just assume, oh, it's just this formula because my teacher told me. No, there's actually a process as to why this is the value of your vertex. So once you get that x value of your vertex, you have to plug it back in because the vertex is a coordinate point. It's on a coordinate plane. So make sure you then plug that in and get your value. So here's our problem to work with. Y equals x squared plus 8x plus 21. I want the vertex, I want the y-intercept, the axis of symmetry, and a symmetric point. Again, later on, you will also be calculating your x-intercepts as well. So to begin with, start with the vertex. The x value of your vertex is the opposite of b over 2a. Here's a, 1. Here's b, 8. And then, of course, c is 21. So to find the x value of this vertex, x equals the opposite of b, so negative 8, all over 2 times a, which is 2. So the x value of my vertex is negative 4. To find the y value of it, I have to plug it back in. This is the part where students sometimes struggle. Vertex is a coordinate point. I have an x value. Now I need to know my y value. So to find that y value, plug it in strictly for all of the x's. So the y value equals the quantity of negative 4 squared. Keep in mind a negative squared is a positive. Plus 8 times negative 4 plus 21. So when I do that, I get 5. Most important part of my graph is that vertex, negative 4, 5. Part of the reason I calculate my vertex almost all the time. Even though my y-intercept is even easier, think about how we find our y-intercept. Y-intercept occurs when x is 0. So plug 0 in for x. 0 squared plus 8 times 0 plus 21. I plugged 0 in for x, and it spits out 21. Y-intercept is when x is 0, and x-intercept is when y is 0. So I now have my y-intercept. My axis of symmetry. My axis of symmetry is the vertical line that goes through the x value of your vertex. Vertical line means it's an x equals line. What is the x value of your vertex? -4. And then the symmetric point. The symmetric point sometimes comes off as one of the harder things to find, but once you know your y-intercept, which we said was one of the easiest, and you know where your vertex is, you have to flip it across that axis of symmetry line, that vertical line. So what I'm going to do is I'm going to plot these points. Because my y-intercept is 21, I'm going to count my squares by 3s. So go ahead and graph this. So the two greens are my dots. My vertex is at -4, 5. My y-intercept is at 0, 21. So if I were to try to draw a U shape right now, I'm missing half of my graph. I know from my vertex, I go from that point and up to the one side. So I have 1/2 of my graph, but I'm missing the other part. And that comes in with that symmetric piece. I have a point that's on my graph. I have an infinite number of points in my graph. But this is one key important point that we found already, 0, 21. So I have to do my axis, or I have to do my reflection to find that symmetric point. So the point 0, 21, if you think about it, from my vertex is 4 units to the right. So 1, 2, 3, 4 over. So therefore I have to go 4 over the other direction. 1, 2, 3, 4. So for my symmetric point, the x value of it is -8. Now, since it's a complete reflection, however far up it is, that's how far up the other one is. So it was up at 21. This one also has to be up at 21. I'm going to erase these dots. And now connect the other part of my graph. And now I have my parabola. Doesn't happen to have any x-intercepts in this case either. But go through, find your vertex opposite of b over 2a. Find that y-intercept, you plug 0 in for x, so it's just the c value. Find the axis of symmetry, do your reflections to find a symmetric point. So you'll practice a couple of these, just get used to this process, keeping in mind why the x value of your vertex is what it is.